Hey guys, so today you're going to learn about matter, and matter is basically everything that you're seeing around you right now. Your packet is matter, your laptop is matter, you are made of matter. Matter is anything that has mass and volume. And so the two parts of that definition mean mass means that it has stuff in it, it's made of something, and volume means that it takes up space. And you are both of those. You're made of stuff and you take up space. So what we need to be able to do is classify this matter and put it into some categories. So you notice that this graphic organizer kind of goes and branches off into two directions. And so there's two big categories of matter. So the first one is when things are pure, they have a uniform, unchanging composition. It's always going to be what it is. It's never going to change into something else. It's always going to look the same. And then from there, if it's pure, we can divide it further. So then if it's pure, there are two more options for classification. It could be an element, which means it cannot be broken down into anything smaller. That's as little as it can go, and that's as pure as it can go. And you'll know if something is an element because last time you learned about the periodic table of elements. So anything that's on the periodic table is an element. So I just picked some of my favorites there, gold and silver, right? Those shiny ones, those are just elements. They're pure, they can't be broken down anymore, and they're matter. Now another option that's still pure is to have a compound. So that's when you take two or more elements chemically combined. So basically it's something that you can write a formula for. So a formula means something like H2O. That's water. You've heard of that forever, right? That means that there's hydrogen and oxygen in that substance. So anytime you can write a formula like that and see two elements in it, it's a compound. So a couple of other examples, there's table salt, which is NaCl, baking soda that we cook with, that has a formula, and carbon monoxide. So you can see the different elements that are in there. Now, if something is not pure, the second category of matter is it could be a mixture. So that's when you take two or more of those pure substances and you mix them, but they keep their own properties. They don't really turn into anything new. So from here, we can also break them down into two other options. I think that one goes this way, actually. So the first kind of mixture that we can have is called homogeneous. So that's a solution, a constant composition. The parts blend together. If you've ever heard the prefix homo before, it means same. So basically if you look at a homogeneous mixture, it's going to look the same all the way throughout. So examples of that would be like lemonade, right? The top of the glass looks the same as the bottom of the glass. Same thing if you like sweet tea. Even steel is a mixture of iron and carbon, and no matter where you look on that piece of steel, it looks the same. If it's not a homogeneous mixture, then it's a heterogeneous mixture. That's an inconsistent composition. The parts can be seen. Heterogeneous means different. So here I can see the different parts that are in it. So examples of that, if you put oil and water together, they don't mix, they stay separate, and I can see the different pieces. Soil, like dirt in the ground, you can see all the different parts that are in it, right? You might catch a worm, there's some rocks, there's some dirt, there's some bugs, there's lots of different things in there. And my favorite, chocolate chip cookies. I can see the different pieces, which are the dough and the chocolate chips. So let's do a little bit of practice. I've got these categories and I've got these substances to try to classify. So first you have to decide, is it a substance or is it a mixture? It is not possible for it to be both. They are opposite things. If you then decide that something is a substance, you have to say, is it an element or is it a compound? If it's not a substance, then it's going to be a mixture, and it might be homogeneous or it might be heterogeneous. So let's think about chlorine first. Chlorine is pure, so I know that it's a pure substance. It's only chlorine, there's nothing else in it. Then I have to decide, is it an element or is it a compound? The way that you can decide is by checking the periodic table. Chlorine says Cl, which means it is just a single element. It's one thing on the periodic table. Next, if I think about water, water is pure. There's nothing else in it. So it's this. Then I have to decide element or compound. Since I know that water is H2O, it's two elements. That makes it a compound. Oh, that was terrible. Write more clearly. There we go. Okay, now if I think about soil, if I went and I got a bucket full of dirt, there are lots of different things mixed in there, so that's a mixture. And if I looked at that bucket of dirt, I would be able to see the differences. It wouldn't look the same all throughout. So if it's looking the same, it's homogeneous, and if I can see the different parts, it's heterogeneous. Because of all the different things in soil, it is heterogeneous. Alright, so now we have water again, but this time there's sugar in it. So there's two things mixed together. But if you mixed sugar in water, it would dissolve, and it would all look the same. You wouldn't be able to see the sugar in there. That is a homogeneous mixture. Next we have oxygen. Oxygen is just that. There's nothing else in it. It is pure. Then you have to decide element or compound. Since oxygen is one box on the periodic table, it is an element. And if you remember, it's actually one of our diatomic elements because it's O2. Alright, I want you guys to try this column, see if you can identify what kind of matter you have there, and then you can check your answers with me. Alright, let's see how you did. Carbon dioxide is pure, and if you've ever heard of it, you remember from bio, you remember that it is CO2. That's the formula for carbon dioxide. Writing that formula, I see that there are two different elements in there, which makes it a compound. Rocky Road ice cream, there's lots of delicious things mixed in there, and the different parts that are in there stand out, so that is a heterogeneous mixture. Brass is what they make like musical instruments out of, like trumpets and saxophones. It kind of looks like gold, but there's actually a lot of different parts that it has. It's a mixture of many different things. But that whole entire trumpet that it's made out of looks the same. You can't see the parts that are in there. You can't see what's mixed in, which makes it homogeneous. Pure air is what you're breathing right now, and we breathe in lots of things. There's oxygen floating out there, there's nitrogen, there's hydrogen, there's carbon dioxide, there's water, so it's a mixture of many different things. But no matter where I look around me right now, the air all looks the same. That makes it a homogeneous mixture. Lastly, we have iron. Iron is pure. There's nothing else in it except for iron. And if you look on the periodic table, it's Fe. Since it's just one thing on the periodic table, that means it is an element. Alright, now you have a whole nother page of practice. You can ask me questions on this, or you can ask me questions on the next page. Good luck!